All right, so today we're going to start section 3.3. It's on parallel lines and transversals. So as we just said, a transversal is a line that cuts across two or more other lines. What's going to be special today is the lines that the transversal cuts across are always going to be parallel. Okay, before we had them drawn, and they could be like this. Okay, there's two lines cut by a transversal, but they're not parallel. Okay. Today, it'll be more like that. So we're going to start off with a postulate about corresponding angles. Okay, let's just look at the diagram I just drew. Angle 1, that's above and to the left, and angle 2 is above and to the left of the transversal. Okay, so they're corresponding angles. If you look at their sizes, okay, look at them carefully. What does it look like? Angles 1 and 2 are what? If you compare their sizes.
Same line.
Well, it's an angle, so we have to talk about the measure.
Oh, same measure.
Same measure, yeah, and they are. Okay, if you have two parallel lines cut by a transversal, then the corresponding angles are equal. Their measures are equal, which means the angles are congruent. Okay, and these postulates that we're going to learn, we're going to have a few more theorems too. Notice the order of the if and the then. The parallel line part is with the if. Okay, tomorrow, we're going to end up switching that. Okay, the parallel line part is going to be the conclusion. So for example, if I tell you that corresponding angles are congruent, that would prove the lines are parallel. Okay, we're going to look at it that way tomorrow. But for today, you're always going to have parallel lines. And in this case, that means the corresponding angles are congruent. Okay, do we need to prove that? Why not? It's a postulate. Okay, this is a fact that I'm going to give you. We don't have to prove it. We're going to use this fact to prove a couple other things. Okay, so here's a diagram of the corresponding angles postulate. Okay, I've drawn two lines. Generally, when we want to draw two lines and show that they're parallel, just remember to put that little arrow on it. Sometimes the book will use it in red, but that's fine. And angles 1 and 2 are congruent. Okay. Any question on the parallel postulate that we just used there? Yeah? Oh yeah, there's all kinds of other things that are congruent, like if you labeled this 3. If we know angle 1 is congruent to angle 2, and actually we're going to do a proof like this in a second, and angle 1 is congruent to angle 3 because of vertical angles, then we know two other angles are also equal. It's actually going to be our next theorem. Yeah, 3 and 2 would be equal. Anybody remember the names of 3 and 2? They are interior. Yep. Alternate interior. If you have two parallel lines cut by a transversal, the alternate interior angles are also equal, based on using vertical angles and that postulate we just learned. Okay, but we'll prove that. Okay, so we're going to have a few theorems about parallel lines and transversals. Okay, all these theorems are on page 143. Okay, because they get kind of lengthy because you're writing the same thing over and over. If two parallel lines are cut by a transversal, then and then it changes for each theorem. Okay, so the first one is your alternate interior angles theorem. Okay, we just mentioned it. If two parallel lines are cut by a transversal, then the two pairs of alternate interior angles are congruent. Okay, I'm not going to draw the picture, okay, for every single theorem. If you want the pictures, they're all on page 143. Okay, but again, if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay, the next theorem, theorem 3.5. This one has to do with the consecutive interior angles. Okay, let's go back and look at the diagram I had. Let's see if we can compare the consecutive interior angles and see if we notice anything. Okay, consecutive interior angles would be like 2 and 4 in that picture. Do 2 and 4 look like they're the same measure?
No.
No.
But they would add up to 180.
They do. They add up to 180 degrees. Yep. And we'll prove that as well. So if you have two parallel lines cut by a transversal, then the pairs of consecutive interior angles are supplementary. And that's theorem 3.5. On a test, you don't have to know the theorem numbers. You could just write, consecutive interior angle theorem. You could abbreviate that a little bit. Okay, theorem 3.6, alternate exterior angles. Okay, in that picture, angle 1 and 5 are alternate exterior. Okay, anybody think they notice anything about the measure of angle 1 and the measure of angle 5? Again, it's not we were not improved anything, but does that picture suggest anything? Yep. They are. 1 and 5 are congruent. And there's all kinds of ways you can get to that reason. If you've proved these first couple theorems, these might help you. But you've got a lot of vertical angles and corresponding angles, so.
Can't you just use corresponding angles and then say 1 and 2 are corresponding, so 2 and 5 are vertical?
Mm-hmm. Yep. 1 and 2 are automatically equal. 2 and 5, those are equal because they're vertical angles. So if 1's the same as 2 and 2's the same as 5, you can do a transitive property or substitution and easily show 1 and 5 are congruent. Yep. So if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. I don't know if we're going to prove that one. I basically just gave you the proof, but we'll do at least a couple proofs. We'll see. Okay, and where you're eventually going to start to see some of these pictures, you're like, well, when would you really have two parallel lines cut by a transversal? Well, later on in the year, we're going to start to talk about triangles. Right? And let's see if I have. And what they're going to sometimes do is they'll give you a shape. There it is. See, like that. If all the sides were equal, that'd be a rhombus, but in this case, that's just a parallelogram. Right? And what I might do is draw in diagonal, like that. And I might say to you, prove that the triangle on the top and the bottom are congruent. And there's different ways to do that. But if you know that this shape is a parallelogram, we're going to learn that that means it has two pairs of parallel sides. Okay, on the left and the right are parallel, and the top and the bottom are parallel. So you can think of this picture as parallel lines being cut by a transversal. Okay? If I had the top and the bottom are parallel, and they're cut by the diagonal, which is a transversal, then those two angles would automatically be the same. Okay, why? Well, sometimes people like to think of it more like that. You're looking at that angle and that angle.
Potentially make that would technically, if you did that, it would be two pairs of parallel lines. You draw another parallel line in there, then that's a rhombus.
Yep.
On one side.
So everyone see that? You get the angle that's below the horizontal, but above the diagonal. And then the other angle here that's above the horizontal, but below the diagonal. Those are alternate interior angles. They are the same. All right? So proving that these two triangles have an angle that's the same, that might be the first step to showing these triangles are congruent. Right? But this is eventually the kind of proofs we're going to get into and spend a lot of time with, proving triangles are congruent. And this stuff comes up a lot. Right. And our last theorem, it says that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Okay, and that one, we probably won't go through the proof, but we can look at it quickly. If you got two parallel lines, and I draw a line that's perpendicular to one of them, anybody give me the reason why it would have to be perpendicular to the other? We can actually use one of the theorems or postulates we already have. Yep.
It's parallel.
Okay, we have parallel lines.
And
So how do I know that it's perpendicular to this one on the bottom? The corresponding angles, and that was a postulate. Okay, or it was back on the other page. Two parallel lines, corresponding angles are congruent. If the top one's a right angle, so is the bottom one. That makes them both perpendicular to that transversal. So that'd be a very easy proof, theorem 3.7. Okay, any questions on those theorems? All right, so let's try to prove a couple. Okay, let's start off with the alternate interior angle theorem. Okay, so I'm giving you that you have two lines that are parallel, P and Q. And I want you to prove that angle 1 is congruent to angle 2. And the only thing that you can use for this theorem is the postulate that was given a couple slides ago. Okay, so take a second, set that up, put your statements and reasons, and see if you can prove that. Okay, you shouldn't need very many statements and reasons. You can probably do it in I'd say under 4 steps, maybe four or less. Okay, see if you can prove that. All right, what should my first statement be? The given. Okay, the given is that line P is parallel to line Q. And that's given. Okay, what about step 2? Denver?
I'm confused. If you see it on the diagram, can you say it's given?
If you see it, like what do you think you see there?
Or you go 2 and you go to the vertical.
Yeah, that's not a given though. Unless they did this, now it's given. It's given that angle 2 and 3 are congruent because they labeled it. Otherwise, if we just see it, we got to say the reason why.
Couldn't I just say,
But what is it?
The reason, definition, well, what's your statement? I don't know.
I said that they're vertical.
So your statement is angle 2 is congruent to angle 3?
No, that I said they're vertical.
That's a reason. So the statement would be they're congruent. The reason, they are vertical. So angle 2 is congruent to angle 3. Okay, but we can't write given for that because they didn't label it that way. But based on the diagram, there's a reason why. Definition of vertical angles.
We just put vertical angles, fine, or do we need definition?
For that one, put definition because it is a definition. I mean, vertical angles, that's okay, but we really should have it as definition to be a little bit more formal.
I just said angle 1 and angle 2 are congruent because it's the law, it's the theorem of alternate interior angles.
Yeah, but you.
Well, that's a theorem, and that's what we're proving. So you can't use what you're trying to prove as a reason in the proof. Okay? But yes, once we prove that, then anytime we look at a diagram again, we can just say 1 and 2 are congruent because of the alternate interior angle theorem. And we'll have proved that in a second. All right. So what else can we say now?
Angle 1 and angle 2 are congruent because of the definition of interior angles.
No, actually, I think there's one more. We might need 4 steps here. There's something else we have to say, similar to statement 2. And the reason's going to have to do with a postulate. Yep.
Angle 1 and angle 3 are congruent.
Yes.
Would that be
Why are 1 and 3 congruent? It's not labeled that way on the diagram, but because these are parallel lines, we should know why 1 and 3 are congruent.
Because they're corresponding.
Yep, that's the corresponding angles postulate. If 2 parallel lines are cut by a transversal, corresponding angles are congruent. Okay, so that's your... So it's corresponding angles postulate. And what about step 4?
definition of would be angle 1 and angle 2 are congruent.
Okay, so angle 1 is congruent to angle 2. And there's a couple different reasons you could have.
Definition of alternate interior angles.
No, we can't use the reason that we're trying to prove yet. Why are 1 and 2 congruent based on, look at steps 2 and 3.
Substitution.
Yeah, you could call it substitution. Okay. Look at step 3. Angle 1 is congruent to angle 3. But angle 3 is congruent to angle 2. So you could substitute in angle 2 anywhere you see angle 3 because they are congruent. All right, so that would be substitution. And now we've proven it. Okay, we've proven the alternate interior angles theorem. So now you are allowed to use that in any proof as a reason. Alternate interior angles theorem. Any question on the proof? Anybody have anything different? I think the only thing you really could have done different maybe is if you switched steps 2 and 3. You could have done that. And maybe for step 4 you could have said transitive property instead of substitution. But other than that, I think your proof should look pretty similar to that. All right, consecutive interior angles theorem. Okay, we're going to prove that one. What does the consecutive interior angles theorem say? Suppose that I just gave you this statement on the test. So now you have to figure out what your diagram is. You have to figure out what the given is. And then you'd have to tell me what you're trying to prove. So the first step would be what is the consecutive interior angles theorem?
2 angles.
Okay, if you can, try to word it as an if-then. If this happens, then, yeah, Denver?
two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary.
Right. So we're basically being given that you have parallel lines, and you're trying to prove that two consecutive interior angles are supplementary.
So if you just gave us that first part, we could prove this?
Sure. You just have to make a
diagram?
Yep. You got to make your own diagram. You have to make a sketch, draw two lines, label them as parallel, and then draw label two consecutive interior angles. And you might need to label a vertical angle. You can label as much as you want in the diagram. Okay. You might not use everything you label. Okay. So in this case, I've drawn two parallel lines, P and Q, and I've labeled some angles there. So given that P is parallel to Q, I want you to prove that angle 1 plus angle 2 are supplementary. Okay, we'll prove that they are supplementary. Okay, keep in mind that new reason you can use now is alternate interior angles are congruent. We proved that. So that fact might come in handy. You have to take a few minutes and try that one on your own. See if you can figure it out. If you get stuck, just let me know. All right, so let's start off with our first statement. Okay, what should my first statement be? The given. Okay, P is parallel to Q. Why is that true? It's given. Okay, next thing I would do, you're going to have to say this at some point, is to use the theorem that we just learned. Okay, based on the theorem we just proved in example 1, what can we say is true in this picture? Yep, Colin?
Angle 2 and angle 4 are congruent.
Yep, angle 2.
The reason is definition of alternate interior angles.
So that's a theorem, the alternate interior angle theorem. Yep. The definition of alternate interior angles is basically just two angles on opposite sides of the transversal inside the two lines. Okay, but this is a theorem. Okay, but that's good. So alternate interior angle theorem. All right, step 3. Okay, step 3 is where we are going to have to talk about measures here. Okay, so based on step 2, I can say that the measure of angle 2 equals the measure of angle 4. What's the reason for that? We've seen this reason a lot whenever an equality statement follows a congruent statement. Yep. Yeah, that's just the definition of what it means to be congruent. Definition of congruent angles. All right, for now, I think that's all we can really say about angles 2 and 4. Okay, let's go up and look at 1 and 4. Okay, what kind of angles are 1 and 4? They form something. Luke? Yes. Angle 1 and 4 are a linear pair. Okay, now in step 4, some people might just be tempted to say, oh, well, they are, they add up to 180. Well, that's not given. That's jumping a couple steps. Okay, but they definitely form a linear pair. That's, by the definition, I would say that's the definition of a linear pair. The non-common sides form opposite rays. So step 4. So definition of linear pair. Okay, and what's the other statement that's related to that? If two angles form a linear pair, then the angles are automatically, they're automatically supplementary. So we can I'm going to allow you to just say that they add up to 180 because that's the definition of supplementary. So we're going to cut that little step out. So measure of angle 1 plus measure of angle 4 equals 180. Okay, what's my reason for that? This is a tricky reason if you don't remember it, but it was on the test. Huh? Not definition of supplementary. It has something to still do with...
Linear pair.
That's the linear pair postulate. If two angles form a linear pair, then they are supplementary. Okay, so on your cheat sheet for the test, that might be something you want to add. Like maybe on one side of your cheat sheet, you start making a list of reasons. So that way you can remember all these different reasons as we add to them throughout the year. Yep?
Like, is it a count on a test where you don't do the column one, you just write out like a paragraph? Because like, you're better just writing a paragraph saying why this is wrong.
Sure, you could, if it doesn't say how to prove it, you could prove it any way you want. Unless it's specifically like it's set up where I give you the statements and then you have to fill in the reasons. It's already set up as a 2-column proof, then that'd be a little different. But in general, if it just says to prove and it doesn't say how, you can do it any way you want. All right, let's look at step 6. Okay, I think to get step 6, we can take a look at a couple steps that we just wrote earlier. There's something else that adds up to 180 now. And now we're getting in the right direction. 1 and 4 add up to 180, but there's something else that we know.
2 and 1 add to 180.
Okay, and how did you say that?
Because 2 is congruent to angle 4.
Sure. 2 is congruent to angle 4. We already said that. So we could use, what property is that when you change that to measure of angle 2?
Substitution.
You just did substitution. Okay, so measure of angle 1 plus measure of angle 2 equals 180. That's substitution. And now, is that what they wanted? No, they said to prove that they're supplementary. Well, we've basically done that. Okay, if two angles add up to 180, then they are supplementary. What's the reason for that? Angle 1 and angle 2 are supplementary based on statement 6.
Definition of a linear pair.
Well, so now we're saying they're supplementary. So that's the definition of supplementary angles. If two angles add up to 180, then they are supplementary. Yeah?
The angle addition also.
No, it is the definition of supplementary angles. Yeah. You don't need the angle addition postulate in this problem. But that's another good reason that does come up quite a bit.
There's a way to do that with the angle addition postulate, no?
With the angle addition postulate?
There's
Well-
a way to prove this with
To do that, generally you got to have kind of a diagram that's set up like this, where you've got two angles that are next to each other, and then if you take both of them together, they equal the whole thing.
Yeah,
Yeah,
but you can
but-
also do that with the linear pairs.
The linear pair, yeah, there might be other ways to prove it. I don't know if there's any that are more direct than that. Okay? I don't think there's any more direct way than what we have here. But there's always other ways to do it. Okay, any questions on that proof? All right, so let's finish up with a few numerical kind of problems. Okay, enough with the proofs for now. So it says that in this case, the measure of angle 5 is 65 degrees. I'm going to find each measure listed below. And then just tell me how you know that. Okay, so let's start with the measure of angle 5. Okay, that's 65 degrees. What would the measure of angle 6 be? Yep.
65 degrees,
Yeah, how do you know that?
because they're vertical.
Sure. 65 degrees, reason. Okay, we're not writing a proof. Just the reason why. Vertical angles. 5 and 6 are vertical. Right, how about the measure of angle 7? The measure of angle 7 be, yeah?
115 degrees.
Yeah, it would be 115. And what would be your reason for that?
Because 6 and 7 are linear pairs, and linear pairs are supplementary.
Yeah, so you have a linear pair between 6 and 7. So we know that they are supplementary. So you got to find an angle that's the supplement to 65, which would be 115. So you're using the idea of a linear pair. You could also say the same thing with 5 and 7. You could do it the same way. Okay, how about angle 8? Angle 8 would be 65 degrees. What's the reason for that? 6 and 8, are they corresponding?
Oh, no.
So no, one's above, one's
Alternate
below.
exterior angles.
Yep, that's the alternate exterior angle theorem. If you got two parallel lines, the alternate exterior angles are equal. Okay, so now we got angle 8. What else do we want? Angle 9. Okay, what's angle 9? It is 115. Yep. And what's our reason for that? Alternate exterior angles? Sure. Yeah, because we already know that 7 is 115. So 7 and 9 have to be the same. Okay. You could have also done, anyone else see something else you could have done? Besides alternate exterior angles? Corresponding would be tricky because we don't know. Let's call this angle 4. Okay, if you knew angle 7, and then you used vertical angles to get angle 4, then you could say 4 and 9 are the same because they're corresponding. Okay, but we didn't find angle 4. But we did find angle 8. So what's another way to find angle 9 if you know 8? Yeah, they're a linear pair. So they have to add up to 180. Okay, so all kinds of ways once you find a couple angles to find the rest. So I think the first thought was alternate exterior angle theorem. And that's it. Any questions on that? And let's look at this one. So it says find the value of x. So now we're going to take some of the concepts we learned from geometry, and now we're going to form an algebraic equation. And using what you learned in Algebra 1, we'll solve it. Okay, is there any special relationship between the two angles I've labeled, 125 and x plus 15 degrees? Are they corresponding? Are they alternate interior? Are they any of the types?
Corresponding switch alternate.
Okay, so yeah, they're not quite corresponding, right? We'd have to have this angle for them to be corresponding. Okay, right in here. But that fact might help us. How much is the angle next to x plus 15, kind of to the left and above it a little bit? How do you know this is 125?
It's our corresponding angle and 125, the top angle.
It's corresponding. Two parallel lines cut by transversal, corresponding angles are equal. Now this is enough information, we could set up an equation.
You know, 180 minus 125, and you get a number.
Yeah, but you have to solve for x.
You have to solve for x by getting 180 minus 125, and it would be 1.
No, that would be the answer.
Oh my god.
Go ahead, try one more. Just tell me what you're thinking. There's a couple ways you can set this up.
It'd be 60 degrees, right, or 60?
So you're saying to do 180
It'd be, sorry,
minus what?
minus 125.
All right, now let's just look at that. If you take 180, which is this whole angle right here, and you subtract out the 125 part, what does that leave you with?
Yeah, measurement of that.
The measurement of the other angle, x plus 15.
Right.
Okay? So there's one way you could set up your equation.
And x plus 15 has to equal
What's 180 minus 125?
55.
Yep, so subtract that. Okay, we get 55.
You subtract 15, 5, and you get 40, and x equals 40.
Yep, so subtract 15 from each side. And x is 40. Yep. So that's perfect. What's another way you could set up this equation? What if I wanted to do it with the 180 by itself on one side? What do we know when that picture has to add up to 180? Those two angles. Okay. The 125 plus the other one, they have to add up to 180. But these two equations, they're exactly the same thing. The only difference is the top equation has x plus 15 by itself, so the 125 is brought to the other side. But they're the same equation. Okay. Any questions on that one? All right, so in the homework, you'll have a combination of some proofs and then some numerical ones to solve. All right, let's finish up with this one. Okay, so our last one is to find x. Okay, anything else I can label in that diagram that would corresponding? Sure. What's corresponding?
89 and
The one that corresponds with 89?
yeah.
So yeah, 89 is above and to the left. So let's go above and to the left. I think it's going to be very similar to the last one. What do we know about the 89 degree angle I just labeled and the one that's above and to the right of it? They're a linear pair, which means what? They do what?
Add up to 1.
They add up to 180. Good. So 89 plus 5x minus 24 equals 180. All right, what would be my first step? About Rose?
You can add 24 on 180.
You know, even before we start moving stuff from side to side, we should simplify everything that's on one side first, if we can. Are there any like terms you can combine on the one side?
89 and 24.
Yeah, what do you get when you do 89 minus 24?
You get 63 and 61.
65, yep. So 89 minus 24 is 65 plus 5x. Okay, now we can start putting stuff on the other side. Anybody see what you got to do next, Luke?
Subtract 65 from 80.
So we're going to subtract 65 from both sides. And what's 180 minus 65? Oh, Alyssa?
Fifteen.
115. And what's my last step? About Justin.
Divide 115 by 5, or 5.
Yeah, just 5. Okay, divide by 5, divide by 5. 115, divide by 5, gives me 23. So x is 23. Now, what if I asked you, how big is this angle? What would you do with the 23?
You know, plug it in.
Yeah, you could just plug it in for x. Do 5 times 23 minus 24. Okay, but in this case, I just wanted you to find x, and we've done that. All right, so the homework on 146 is 3 to 6, 8 to 16, 18 to 23, and 28 to 29, and that's all. Okay, for the MCAS, okay, try questions 1 through 4 on the multiple choice.